Welcome friends to the NPTEL MOOC module on handling healthcare dataset, healthcare survey dataset. We are on the verge of second week and we are trying to explain going for the field, the requirement of going for the field survey for healthcare research, especially understanding type of sampling and sample size determination. So, sample size determination, as we already pointed out in the last lecture, is very important, and then it connects to your margin error, it connects to your standard deviation, or it connects to your confidence level. Okay. So, those clarification I have already given in the previous lecture. Now, we are concentrating on the sample size determination, and a special technique nowadays utilized is called probability proportional to size sampling. Now, in the very backdrop, I just wanted to mention that a sample is a group of people and objects or items that are taken from a large population for measurement. Sampling can be done using either probability method or by non-probability sampling method. Random sampling, as we all know, that is often used, and this is with probability proportional to size sampling. And in fact, random sampling with probability proportional to size is a type of probability sampling. The genesis of Ppa sampling is attributed to Brewer and Gregoire. So, to its use in multi-stage sampling by Hansen and Hurwitz. PPS is a sampling procedure under which the probability of a unit being included, and that is proportional to the size of the ultimate unit. When PPS sampling is used, a larger sampling unit has a higher probability of being selected into that sampling. Probability proportional sampling is used in survey research when the sampling units vary in size. Okay. So, this is important. When the sampling units are very heterogeneous, probability sampling technique is suggested. Other important aspect that the researcher want to take into account in the sample design as well in the PPS technique. With the probability proportional sampling, the inclusion probability for each sampling unit is different and is proportional to an auxiliary variable, which is usually a size measure for each of the sampling unit. The size measure can be a measure of population size or geographical area or geographical size of the sampling unit. A composite measure of other related information about the sampling units depending on the purpose of the survey is also considered in the PPS. PPS is widely used in survey research with multi-stage design. Many large-scale social surveys with complex sample design have implemented probability proportional to size sampling in at least one of the sampling stages. For example, PPS is used in National Family Health Survey NFHS, National Sample Survey NSS also, and Health Retirement Survey as well. Now, we are discussing about a bit of discussion on sample size, what it requires and how it is relevant, what parameters it urgently required to estimate. It is based on the extent of precision in the result and the confidence level. First aspect we are calculating is when the sample size is estimated, given the fact that we are estimating at a mean level. Sample size when estimating a mean, we require the confidence interval of the universe, that is mu. Mu at the mean level, mu is defined as the x bar plus capital X bar plus z times standard deviation by square root of n, that is sample size. So, capital N is the size of the entire population, and small n is the sample population, and E is the acceptable error, and that is also called the precision, and sigma is in fact the standard deviation of the population, and Z is the tabulated value or the confidence level, standard variate at a given confidence level. Okay, that is the standard variate or standard tabulated value at a confidence level. So, Z is determined accordingly. Now, based on that, and this is our population mean. Okay. Okay, based on this, we can estimate our margin error, that is E is nothing but the mean value plus minus Z times it's a standard deviation, so standard error. Okay, so it is basically this Z times G times sigma by square root of n. So, from there we can calculate the sample size. So, sample size is here. This is basically G square into sigma square divided by E square. E is our acceptable error, the margin error, which I have guided in the previous class, previous lecture, and G is the tabulated value at a certain confidence level, and sigma is the standard deviation of the population if it is known. Now, in case of finite population, this is what we said in the previous one. We said it is in case of when the population is capital N is not known. Okay, from the sample mean we have calculated. But when we have a finite population, we know that this is our finite population. In that case, we are supposed to multiply with this portion. Okay, this is capital N minus a small n divided by n minus capital N minus 1. So, accordingly, we have this component, and from there we solve it. G square into n times n is coming here, and minus 1 is here times E square and all. You can solve it and you will find out this answer for sure. Okay. Now, one example we can cite it here, like one researcher want to collect cross sectional data on past alcohol habits and current diagnosis of liver disease. Okay, and whether and to determine the size of the sample for this universe of n is of 5000 on the basis of the following information. So, we need to find out the sample size. Given the information that the variance is 4, the standard deviation is 4. Okay, so the variance is 4. So, the standard deviation is square root of this 2, that is 2. On the basis of past record, there are variance of the distribution is given as 4. Our estimate should be within 0.8 margin error of the true weight with 99% probability. So, the G value is 99% confidence with confidence level of 99%. Okay, and the margin error is of E of this much 0.8, and our capital N is given. So, when your capital N is given, that means you have to apply the second formula, that is N is given. In that case, we are applying this formula which we have derived in the previous equation. Okay, so the G value at 99% confidence level, the G value is of 2.57. Okay, at 95% 1.96, G value is 1.96. And E, the information is given, margin error is 0.8. That means your result will be differentiated by plus 0.8 and minus 0.8. Okay, your GZ value could be differentiated by this margin error. Now, your standard deviation is 2. All the figures we have got it. Once we apply it, we got a sample that is small n is equal to 40.95. So, in a round figure it is of 41. So, 41 is your sample size given this information. Similarly, when instead of the exact standard deviation or those figure, if you are given information about proportion or the percentage, when we have to specify the precision and confidence level, the confidence interval for proportion, that is p hat is given by p plus g times p into q divided by n. When it is like a Poisson distribution, when this information is given. So, we can able to calculate the acceptable region. This is what is our acceptable region, our margin error, and E is equal to g times square root of Vq by n. From this we can able to calculate the n value, and this is also suggesting the fact that P is your probability of inclusion and Q is non-inclusion. Okay, okay. Now another formula we have is called Bryman's formula of 2016 formula. This is what based on this, based on the proportion instead of the exact figures. If it is not there, then if it is proportions are given, then look at in the place of sigma, we have actually taken P into Q. Okay, P into Q, rest are more or less same. All right. Okay. So, this is again sigma. In our earlier equation it was of sigma. Okay. So, and this is P into Q. All right. Okay. Sigma square, sorry. Now, based on this formula as suggested by Bryman, in case of finite population with n is given, and we can able to calculate. Another suggestions given by Cochrane formula for calculating sample size when population is infinite. It has given another formula. You can follow this example. I am not emphasizing much on it. It has simplified the formula. Cochrane 77, the earlier suggestions. If it gives
margin error, its confidence interval, and some if any proportion is not given, some guesstimates could be taken, like p percentage, suppose traditional medicine, right, like if you are testing how much sample size we should take about to understand the nature of treatment during COVID-19. How much percentage researcher want to check the nature of treatment during COVID-19 in districts. So, it might be the case that the nature of treatment is taken by 30% of the population. Some guesstimates would be taken, or some based on certain literature, certain idea, we can take the p value. So, based on that the margin error is calculated. Likewise, we did in before. Now, here our Z score in different context, if it is of 90%, Z value is 1.645, if it is the 1.96 or 2.58, case of 99%. So, first of all we can find out the sample size given the n based on the formula which I have suggested. So, 1291 is the sample size. Okay. So, we would need around 1300 or 1290 or 1300 people at 90% level of confidence. Okay. Now, for which we have taken 1.645 as the Z value. Okay, okay, like at 1 point Z value we have taken 1.96 at 95%. If you are taking at 90%, that is by taking Z value, when your confidence level reduces, your sample size would be lesser. Okay, sample size we can find out that it is lesser. We have changed the confidence level, the rest are same. Now, when we do not have any idea about proportion, we used to take about when we have certain idea, we take proportion. When we do not have any idea, then 50% could be assumed.
50% of in favor, that is 0.5. And when your proportion of inclusion is higher, you are supposed to take more person to be surveyed. Now, Cochrane formula is used also when we have finite population. In that case, in the previous example we said about infinite population, case of infinite population, and this is for when population is infinite. Okay. Now we said when it is finite, first of all we have to find out the first value. Like a researcher wants to assess the mean health expenditure for all homeowners in Rajasthan. For example, a survey 10 years ago got a sample mean and standard deviation of 1400 and 1000. Okay, standard deviation, it has got a sample mean, okay, of 1400 and 1000 as the standard deviation. How many households should be sampled with 95% confidence interval to have a margin error of 100? Okay. With margin error of 100, how many what is the mean health expenditure? Does it vary from 1300 to 1500? We are going to find out. First of all, N0 we will calculate. What is the N0 based on this? When we have a finite population, we said that our population is finite. Alright, based on this formula, we calculated our S in this case is 1000, that is PQ. In the place of that we have taken sample error 1000, and T value we have taken at 1.96, and margin error is of 100, and we get N equal to 384. So, N is here is the sample size derived from the equation of Cochrane, and capital N is the population size. So, we are now going to calculate. So, small n is equal to capital N divided by 1 plus n into E square as per the EMNA formula. What is the Ni? Ni in fact the sample size of this particular category is the particular ratio of sample from the group is taken. N is the total population size and E is the acceptable sample region. Like here you can understand, I think I have mentioned it. Okay. As per the EMNA formula, your population size, if it is given in different number, all right, with 5% plus minus confidence error, 5% error, or 5%, 7% error, or 10% error, its margin, its confidence level at 95%, different sample size, how they are calculated is given. So it's if they have different population, you can mention the population and like this, and you can able to calculate your individual n. Like I will point out here in this example, suppose we have the n is the sample size, and capital in the population size is of 10 lakh 72,756 and 83 in 1,286 household rural and urban areas in 2 districts respectively, if that is the n available in 2 places. E is the acceptable sampling error of 5%, that is 0.05. For 2 districts in Odisha, if based on my own survey, based on the personal, we target for a personal interview. That is present in the appendix, but now I am not going to see the appendix. I can calculate. I can just simply mention it here. The total number of urban households in Balasore is of 47 lakh 360, and in Moyurbhanj district, okay, in Balasore district of this much, and this much in Moyurbhanj district. The total number of samples selected from the urban areas as per the EMNA formula
is of, if you apply this formula, you will find 400 households. Similarly, another 400 are selected from rural areas with this formula based on the 2 district and the sample and its population size. So, total sample to be taken is of 400 plus 400, that is 800. So, EMNF formula actually gives you it's pretty easy to find out the sample size. Okay. So, what are the thumb rules? In this case, thumb rules are like the larger is the sample size, the more accurate your estimate is, and the sampling error is inversely related to the size of the sample, which I have already said. The size of standard error depends on the size sample size to a great extent, and it varies inversely with the size of the sample. If double reliability is required, then reducing samples error to half of its existing magnitude, the sample size should be increased to 4-fold. This is what is suggested by the studies, that if you want to get double reliability by reducing your sample error to half, then you are supposed to increase your sample size to 4 times. Okay. What do you mean by central limit theorem? This assures that sampling distribution of the mean approaches to the normal distribution as the sample size increases. This is what we will be drawing every time in our sample. It should be representative, that is what is suggested by the central limit theorem. The fact holds especially true for sample sizes over 30, that approaches to normal distribution. The smaller your sample size, the more likely outliers you have unusual pieces of data, and these are usually skewed. Sample size, if it is large, more than 30, suggested for Z test, and other details we have guided in the previous lecture. If it is your study is qualitative, fewer samples should be taken, and if it is quantitative one, then larger samples should be taken. There should be a 10% thumb rule, 10% rule for sample sizes may be taken, but still it is too high in number. An assumption used for nearly every statistical test is that t test or NV test etc. is that the sample size should not be more than 10% of the population size, where the population size is known. Okay. After saying all those understanding about sample size determination, now we are categorically emphasizing on PPS, probability proportional to size sampling. There are some steps involved in the PPS. Okay. First stage is like larger cluster have higher probability of being sampled. Second stage is sampling exactly the same number of individuals per clusters. The individuals in larger clusters have smaller probability of sampled. Okay. Overall, the second stage compensates the first stage, so that each individual in the population has the same probability of being sampled. So, I will discuss. We need to first calculate the sample size for each strata, separate population into strata. In the second stage, the following steps will have to be applied for each strata. So, we need to list the PSUs, primary sampling units, and as per the column A, we will discuss this. Okay, and I will come to it. And their population size in column B, like in column A, we will put in our Excel sheet, we will put the PSU, the unit, and their population size will be in column B. I have one sample example for it, I will show it to you. Then each cluster has its own population size, each cluster wise we can calculate. Then you calculate cumulative sum of the population sizes. First we need to make them in ordering, ascending or descending, then we make the cumulative population of those size. Next step is to calculate the cumulative sum of the population sizes, that is the total population should be in the column C, cumulative population could be listed. We will determine the number of cluster, how many cluster we need to make, that will be sampled in each strata. Then determine the number of individuals to be sampled from each cluster. When you define the cluster, then individual sample could be taken from each cluster. I will get to you.
Then next step is to divide the total population by the number of clusters to be sampled to get the sample interval. So, sample interval is important, that is basically number of population, total population divided by number of cluster. From each cluster how many sample you are supposed to collect. Choose a random number from first to the first to the sample interval, and this is in fact the sample random start. This is also called random start. Likewise, we follow in the systematic random sampling. The first clusters to be sampled containing the cumulative population in the column C. Then you calculate the following series, the random start plus interval is your second unit to be selected, random start plus 2 sample interval is your third unit to be selected. Similarly, the nth item to be selected like random start plus d minus 1 times its sample interval. Finally, the clusters selected are those for which the cumulative population contains one of the serial numbers calculated in item number 8. Depending on the population size of the cluster, it is possible that B cluster will sample more than once, okay, and mark the sample cluster in another column, that we will mention it. Then we calculate each of the sample clusters, the probability of each cluster being sampled, that is probability 1, we can point it out in column E about the probability. So, probability is equal to 1 times D divided by B, A times D, A is your cluster population time B, D is your number of clusters, okay, divided by population is your probability. So, probability of their inclusion could be also included. Second one, calculate each of the sample clusters. The probability of each individual being sampled in each clusters should be given. Probability 2 like C by S, A is your cluster population and C is your number of individuals to be sampled in each clusters. Okay, number of individuals to be sampled in each cluster. You can follow it through my example and I will be guiding it. So, then we calculate the basic weight of each of the individual being sampled in the population. The weight is simply inverse to the probability of selection. The basic weight will be inverse to its probabilities, like 1 upon probability 1 times probability B, that we can do. Here is the example how we followed. First of all, we make a clusters, a group of population out of the total. Now, first cluster, likewise in India clusters are like blocks in districts, in a districts, okay. So, each block, let it be one cluster, like 30 blocks are there, then their individual population size is given as A. Okay. In the C, we have taken as the cumulative sum of those. Another easiest way to do the size of the population, you can make it in increasing order and decreasing order. Then you can also take the cumulative order in C. Okay. Then you follow the C. From the C, we can identify like our total population is 20,000 here. Okay, the population is 20,000 in 30 clusters. So, 30 clusters are there. Sample 3,000 from 10 clusters using PPS. So, sample of 3,000 from 10 clusters using PPS, that we can do it. Let us understand this. Now, first of all, calculate the probability 1 and probability 2. What is this? After like 3,000, if out of 20,000 we can get each of those numbers. 905 2 2905 cluster sampled, like 2095 4 then 4905, those numbers could be taken based on the sample interval. I will guide it from another simplified data, but here you can just see how to calculate the probability of selection of each sample cluster. Probability is of 90 in the E column we have mentioned a probability, that is 51%. Then this is of 65%, the next cluster is included, okay, and then it is number. Then similarly other probabilities could be calculated. So, basically probability 1 is equal to probability of selection of each sampled clusters. Probability 2 is equal to probability of selection of each individual in each of the sampled clusters. So, each individual is 300 if that number is allocated 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 into 300 basically 3000. So, like this 300 if you simply take it, that 300 out of the number is of 29 percent, then here 300 out of this is 23%, so and so on. Now, basically what is the overall weight? This is basically inverse of P1 into P2. So, inverse of the probability of each individual being sampled is basically P1 and P2. So, this is your 29%, 51%, this boils down to 6.7%, and accordingly every time it seems you have a same overall weight. Okay. Now, number of clusters is 10. Sample interval here is our cumulative population, that is 20,000 divided by 10, that is of 2000. In every 2000 we are supposed to take 1. So, the random start here is of 905 out of 2000 population till 2000. First start is till 2000 population. Out of 2000 we could have taken this is till 2000 population. We have got one random start, that is 905. Then 905 plus 2000. 905 plus 2000 is our 2905. This is plus 2000 is our 4905. Similarly, plus 2000, so on. So, this is what all the numbers are selected. So, this one is selected 1, 2, 3, 4 from each cluster which one is selected. Now, per individual cluster how many are selected, that is as per the choice. Now, I will tell you how it is selected. So, series numbers are like 905 to 905 I have just guided. I think that is pretty clear to everyone. Probability 1 is equal to A into D times B, that we have already said. Probability 2 is equal to C by A. Overall weight it is 1 upon both of the probabilities. In the lossy sampling design and use of PPS, I think what they have followed, you can follow our lossy database, lossy questionnaire, which I have already discussed in the previous lectures. That in the stage 1 selection of PSUs are there. PSUs are selected using PPS sampling with the number of households in a PSU as a size of measure. The selection of SSUs, secondary sampling units, SSU, like following the allocation across rural and urban areas, the required number of SSUs were selected using PPS sampling again. Yeah, that is using the number of households. NFHS 4 sampling also use PPS, and they considered villages in rural areas and census enumeration block in urban areas to select the sampling unit. Like in my own study, I did a survey in Odisha, where 2 districts were selected for a study, that is one is Khordha and then Morbhanj. This multi-stage sampling method applied, but in the process finally to select the villages from out of so many villages and their population, finally the village selection were made through PPS. Here also the census enumeration blocks were collected through PPS techniques. Okay. And here I think the PPS shortlisted your number of villages to be selected. Now, PPS I will also give you the step, like the PPS is used when communities may vary considerably in population, which I have already said. In diversified population, both simple random sampling and systematic sampling put the same probability to a large as well as small communities, which is incorrect. One way of compensating these differences it is it is important to choose the clusters from the sampling frame with probability proportional to size sampling technique. The household in the sample will have an equal chance of being selected and hence self weighted, which will simplify the analysis. I think in this case I will suggest that you should follow the NFHS report, and it has guided how you can go for following the PPS techniques. Some of the steps I have already guided. You can also follow these steps once again. You assign a number to each of the community, then you list those community by their population. Okay, that is the second on the second column. On the third column, you can make them in cumulative population. Then the next aspect is to calculate the sampling interval. Now, how many sample size you require, and then what is the interval from there must be a systematic ordering followed to define to select the sample. The sampling interval basically is calculated based on cumulative total population divided by number of clusters. Okay. And then to select a random start number between 1 and the first sample interval. Then you can look back the table and choose the village whose cumulative population exceeds this particular number. And then we keep on adding the sample interval, and the next cluster or next village can be selected. Okay. Similarly, we can follow and find out the number of villages to be selected. The sample interval is basically the cumulative population divided by the number of cluster required. This is just for my own data. From my own data, this was the total number, and we number of required number of clusters was 6. From each of this unit we are supposed to select our samples. So, you need not get confused with these numbers. These only gives a rough idea about your each clusters. This first cluster would be from 1 till this 1,07,238. From the next cluster, one suppose you are selecting one number from the first cluster is around 1 lakh. Then you simply add the sampling interval, that is 1,07,238. That would be your second unit to be selected for the sample. Okay. So, these are the way by which you can follow. If you still have some difficulties in understanding the PPS technique, I will suggest that you will either follow LASI report, or you may follow the National Family Health Survey report. This has given systematic guidance about that probability proportional to size sampling, and this is highly utilized these days, especially in the multi-stage sampling procedure or in the large scale survey data set. These are all for today. I look forward to your participation in the next class further on these issues. With this, I think I should close here.